in middle school now. We're completely inexperienced.
What happens here with the infinite geometric series, guys, let's not worry about anything. I have something funny here.
And they are.
Infinite geometric series, look, it's infinite. It goes on and on and on.
Does it ever actually stop?
What, ever stop replicating them?
No,
You just like keep
I
going.
have an infinite cloner.
Nice.
You tried so hard on that one.
No, I didn't. So here's what's happening. If you take a geometric series,
Oh wait, what? Is this still 11-3?
this is 11-4. If you take a geometric series, remember, a geometric series is just the sum of a geometric sequence. And what's happening here is you're just adding more and more to it. So it's 1/2 plus 1/4, 1/2 plus 1/4 plus 1/8, 1/2 plus 1/4, 1/8 plus 1/16, 1/2 plus 1/4, 1/8 plus 1/16 plus 1/32, and so on and so on and so on. What's happening here is that they're trying to figure out, well, what would all of this add up to equal if you were able to get towards infinity? What is it approaching? Well, that's what this is doing. What's that? 1. In this case, this is approaching 1. Now, what you're going to be able to do here is use this very, very simple formula. The sum of a geometric infinite geometric series is always, always, always.
42.
No. I just said this one was 1, so it's not 42. Your first term divided by 1 minus the rate.
Wait, so what does the S stand for?
The sum. The S, when it's just S all by itself, that means it's the sum of the infinite geometric series.
So it's the sum of everything in it?
It's first term over 1 minus the rate. But there is,
Wouldn't that be infinite then?
no, I already, hold on 1 second. Yes, ma'am. No, thank you for reminding me. Give me a minute here, and I will show you. I ran off a copy of what the formula sheets are going to look like that you guys will have for every test or quiz from here on out, including the final. So I'll give that to you guys here in a second. What's happening here, remember, is obviously you're never going to get to infinity. But what is it approaching? What is the value that it would be equal to if you could get there? In this case, 1/2 plus 1/4 plus 1/16 plus 1/32 plus 1/64 plus 1/28 plus 1/256 plus 1/512 plus 1/1024 plus 1/248 plus 1, and so on and so forth. You're eventually going to get closer and closer to 1. So the sum of that series would be 1. That's all it needs. Okay?
Alright.
Now, as you go through this, there is one rule. The only rule that you have to pay close attention to is that your rate, the absolute value of the rate, has to be less than 1. Okay? The absolute value of your rate has to be less than 1 in order for it to have a sum for the infinite series. Okay? Now they write.
No, you can
Go ahead.
go. I would say if it's 1 or more, would that make the sum equal infinity?
What's 1 minus 1?
That's a good point.
I can't divide by 0, can I? There you go. That's fine.
And you can't have the negative for the answer, could you?
But see, so if it was more than 1, you can't have you can't divide by a negative number either. So what if it was like negative? It was like 1 minus 4, and then it was like -3.
There are little rules like that, yes. That's why just remember the rate has to be, the absolute value of the rate has to be less than 1. That's all. That's all you have to remember. Now, remember, we wrote out these rates in generic form. We wrote them out as first term r to the n minus 1. We wrote it like that, where it would be 3 parentheses 1/2 n minus 1, where 1/2 would be your rate. 3 just happened to be the first term. It doesn't matter what the first term is. All you're doing here is you're looking to figure out what the rate is. That's all. So you look at something like this. I find the sum of that. What this is asking you is find the sum of the infinite geometric series where 3 is the first term and 0.7 is your rate. This is just mirroring the idea. This is just saying sum of an infinite geometric series where your first term is 3 and your rate is 0.7. The sum of the first term over 1 minus the rate. 3 divided by 1 minus 0.7. What's wrong? Hey guys, anything, yeah. Well, remember sometimes they wrote this out as an I, sometimes they had it as a K. It's just whatever the variable is. It doesn't mean that it's square root of -1. It's, yeah, that has nothing, and I hate the fact that they flip around I values every once in a while. Don't worry if you see it, just treat it as a variable. All right, that just means it's just any variable. So in your calculators, you have that alpha y equals with the fraction bar. You type it right in and hit enter, and there's your answer every single time.
Is this all we're doing today, or is it just quiz?
No, that's really about all we do. Alpha y equals 1 divided by 1 minus 0.7.
3.
This was 3.
Oh, sorry. Whatever, it's 10. The answer is 10.
Those calculators suck on screen.
They do, they're horrible, they're so very slow. Okay. What this is mirroring here, this is mirroring a sub 1 r to the n minus 1. Where this is your first term and that's your rate.
What does the I equal 1 mean?
It's just a variable. Just variable.
What is the rate?
This is where it starts at, Hunter.
That's just, yeah, that's just where it started. That
Oh, that's
three,
what
it's the
term?
first term, second term, third term. That's all.
So if that were like, if I equaled 2, then the.
You'd start at the second
6.
term. Yeah. Good.
Why did I get pulled over? Because it did not have a real.
That was awful. That was good. I like it. In this case here, again, we have an infinite geometric series. What's the trick anytime that you have a 1 for your first term to figure out your rate? It's just the second term.
Yeah.
Whenever 1 is your first value in a geometric infinite series or a geometric series, your rate is always the second term. Okay? So in this case, my rate is what? Negative 1/4. So my first term is 1. My rate is negative 1/4. So the sum is first term over 1 minus my rate. 1 over 1 minus a negative 1/4 equals. So you get 5/4 and you get 4/5. All it is substitution, guys.
Pretty easy.
Wait, what is it? I thought the rate was.
Negative 1/4. What's 1 minus negative 1/4?
1 1/4.
Is that a T?
Okay.
So what's the answer? 5. 1 over 1 over 1 over 4.
No, simplify. Use your calculator. Don't try to do it in your head. You get it wrong.
I think the answer is 1 over 1.
Oh, just type it out. Is it this complex fraction? It's complex fraction. You want complex fractions.
Alpha y equals 1 over 1.
In this case, what's your first term?
2, 5. Is it 0.8?
Matt, use fraction. Got that right.
Same.
What's your first term?
5.
5.
5.
What's your rate?
1/4.
Bless you. So 5 over 3/4. If you type your if you use your calculators with the fraction bar, and you type it in the way that it's written with the fraction bars, it'll automatically give you an answer with the fraction. Should we make this more difficult?
No.
Just
Murph, just leave it how it is.
Didn't add A's.
If it's not broken,
All right, here we go. We have this generic formula, the sum, your first term over 1 minus r. How many variables do you see? 3 of them. There are 3 variables, so all I have to do is give you how many of them, and you can solve for the other.
2.
Okay.
3.
So in this case here, I'm going to give you the first term, and I'll give you what the sum is. You need to find the rate.
Yeah, how do you do this?
It's a 2-step equation.
Multiply by 1 minus r.
Yeah. Isn't this fraction equal fraction? How do you solve fraction equal fraction?
I did it.
Multiply by the denominator. 10 minus 10.
Divide both sides by 10.
Equals
1 minus r is 2/5. Add r, subtract 2/5. You get 3/5.
Yeah, that was pretty easy.
That was way more than 3 steps.
Oh, quick
That was way more than
rewind.
2 steps, I bet. I didn't
Yes, sir.
do that. Dodge.
I did, yeah, that's how I got it.
okay.
That's how I got 10 times 1
Oh,
minus r.
that's a good idea, because then you don't even have to send the 10.
There's a couple of different ways to set these things up.
I'm talking to Murph, but
I didn't hear you. I'm sorry, what did you say?
I said it. I like that you divided by 10, so you didn't have to distribute it.
Yeah, no, there's no reason to distribute.
I did.
Oh, I did it just in my head. It's just time.
Yeah, you don't, I mean, you don't have to, okay? You don't have to. This is, to be honest with you, this is kind of really all there is to this. What we're gonna work on next week though, is that we're gonna bring back in some of the word problem style for sections 2, 3, and 4. And then we're gonna write recursive rules after that. And that's basically using the a sub n and writing it in terms of statistics. It's one extra step. And then we'll test out of it. My guess is we'll probably be done with this chapter by Thursday.
Oh, wow.
You're gonna be
Test on Friday or test on Monday?
We'll probably do it on Thursday.
Wait, so we'll finish Thursday.
Be a good test.
Wait, we'll finish Wednesday and then test on Thursday.
If you subtract 1 from both sides, and you'll have negative r equals negative 3/5.
Why do you go from 2/5 to
It's so not.
I add r. 1 is 5 over 5 minus 2 over 5. Gives me 3 over 5.
It's not from the 2/5.
Said someone in his class was the one who got
And I did a lot of it. We did a lot of that quick stuff in our head, so that's why.
You should
Okay.
get Josh's Skyrim.
I want you guys to do these. What page is this?
Yeah, I thought you were just.
It's on 668, I think. No, 678. Page 678. Once this loads here. Who, me? Of course I do. I'm a professional.
You should. Hey, try it out.
I thought you did. I almost did. Did you tip it?
It's so weird because
On 678,
Yeah, I was like, why is he?
sooner or later, I want you to do 17 through 37 odds. Okay? You should get it done before you get out of here. Everybody else has. 6, 7, 8. I'm trying to get this to load in here.
What numbers? Wait, up from the book?
Yeah. No, I think I broke the computer.
What number?
I broke the computer.
I don't have my book.
17 through 37 odds.
17.
Odds.
That's a lot.
Hey, Mr. Murphy, this is our only homework all weekend.
That's 12 problems. Minus 4. How we get out and find a billion?
Why is this?
Yeah.
Trevor!
Everybody knows.
Stop.
Murph, can you leave that up there?
Yeah, I'm trying to get it to load and nothing wants to work here.
Page 678. Wait, I meant can you leave that up there? Wait, what did I say?
I can't get this thing to stop. There we go. No,
I'm so confused, Mark. Number 17 is a trick question.
no, it's not.
Rate equals 1. The rate is 1, right? No,
No,
the rate's 1/2.
right.
And it starts at 1?
You don't. Who cares where it starts? It doesn't matter.
We need to know for the equation.
What's the first term? What's a sub 1 there?
1.
1.
That's what I said. That's what we said. You're like, it doesn't matter where it starts.
Oh, you guys were talking about something else, I thought.
Oh, yeah.